Hi, this is the Dynamics project for Andrew Amesbury, Andrew Budd, and Jess Kopak. So, you're in a dilemma. Your Little League baseball team is in the World Series. It's the bottom of the ninth inning, the game is tied, bases are loaded, and you're up to bat. So, which bat do you choose? Bat 1 is heavier, but because it's heavier, you swing it slower. Bat 2 is lighter, but because it's lighter, you swing it faster. So which one's better?
So the first thing you have to do is determine the linear velocity of each of the bats before hitting the ball, which you do by multiplying the angular velocity times the radius of rotation. So in order to determine which bat we should use and which bat will produce the furthest line drive, we can essentially treat this problem as a collision between the bat and the ball. As you can see here, this is before the collision. The bat and the ball have velocities towards each other. And then after the collision, both are going in the same direction. So we can use the conservation of linear momentum to find out the velocity of the ball after the collision. But we don't have V2A, which is the velocity of the bat after the collision. So we need to determine that from the coefficient of restitution, which is why we introduced that here. So by combining the two equations, we can solve for the velocity of the ball after the collision. All this right here is the algebra. You can pause the video right now and check and make sure that I didn't make any mistakes. So as you can see over here, this is the final solution that you come to, which solves for the velocity of the bat after the collision by using the coefficient of restitution, which in this case is 0.55 for both cases. So for bat 1, we essentially plugged in the initial velocity of the ball, which was 90 miles per hour, and that translates to 40.23 meters per second. And then essentially fill in the rest with the mass of the ball and the bat, and then our coefficient of restitution. So by doing that, we find out that the velocity of the ball after hitting bat 1, which is our heavier bat, has a velocity of 4.36 meters per second. And then if we do the same for bat 2, which is our lighter bat, but you can swing it faster, we get a velocity of 14.817 meters per second. So it turns out that it would be better for the Little League player to use bat 2 to produce the furthest line drive.
Oh, hey there, were you wondering about the concepts of our Dynamics project too? Because I was. Really, the most important concept is the conservation of momentum, because that's what allows us to calculate the velocities of the ball and the bat after the central impact. Coefficient of restitution is another property of the bat and the ball that helps us determine the velocities. And then earlier on you saw Andrew calculate the linear velocity of the bat based on the angular velocity. In real life, the situation is not going to be anything like it is in the project. Things like the coefficient of restitution, different angles of the ball and the bat colliding with ij and k components, and the rotational energy of the ball are going to completely change the actual dynamics of the situation. But for simplicity's sake, we made everything a lot easier. And lots of research has already been done on this topic, so we're not really discovering anything